All right, so for the practice exam, question 4 is the first question we've got. And yeah, as it comes up, Blake, I'll talk about it. Right, showing is the accompanying image, General Lewis dot formula. The number of unpaired electrons present in the valence shell of this, right? So our unpaired electrons, I've got 1, 2 unpaired electrons. The number of paired electrons in the valence shell of this member of the family. So for pairs, right, I've also got 1, I've got 2, the number of paired electrons. So we've got 4 electrons, but they're in 2 pairs, right, for that. And then the chemical symbol of the second member of this family. So the important thing to answer this question, right, there is 6 electrons total. So 6 electrons puts us in group 6, right? And then we go to the periodic table of the elements, right? In the periodic table of the elements here, there's a good spot for it. Group 6, right? Group 6 is this group here. So the second member of this group would be sulfur, right? A few of you got this wrong and were asking me about it because it asks for the symbol, and many of you just spelled out sulfur. So just read the question, answer the question that's written. Chemical symbol is S because it's just sulfur. All right, question 6. Answer the following questions about dimethyl ether, right? How do we know where in the column it is, right? We know where in the column it is because we know our number of valence electrons, right? So 1, 2, 3, 4, 5, 6 valence electrons. 6 valence electrons is group 6, so that matches, right? Our valence electrons. Right? Group 1 has 1 valence electron, group 2, 2 valence electrons, right? 3, 4, 5, and 6. So it has to be oxygen, sulfur, selenium, tellurium group. And then it says in the second member of this family. So second one, oxygen is first, sulfur is next. Yeah, thank you, Todd. And so it's not asking, right? I've got 2 electrons that are unpaired. And then the way I read the question, it's asking for the number of electrons that are paired. So we have 2 pairs, but there are 4 electrons in those pairs. I mean, just to make sure, like I read the question as what are the number of electrons that are paired? There's 4 electrons that are paired. That's how I read that second part of the question. All right, for question 6, answer the following questions about dimethyl ether. Ether, we draw that Lewis structure, and we've got oxygen in the middle, and we're flanked by carbon on both sides. So the total number of valence electrons in the structure. So let me just erase this, and I'll draw the valence electrons in this. So oxygen will be blue, right? The valence electrons from oxygen will be blue, carbon will be red, right? 1, 2, 3, 4, 1, 2, 3, and 4. And then hydrogen will be blue as well. So there's that, that, and that. So total number of valence electrons in the structure, right? I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. The central atom, right? The central atom in this case, they show us what the central atom is, right? So the central atom is oxygen, and the central atoms guess they're looking for carbon as well. And there's a total of lone pair electrons on the central atom, right? So our lone pair electrons on the central atom got 1, 2 lone pairs of electrons. And there are blank, single, double, and triple bonds. So there's 0 triple bonds, 0 double bonds, and then for our single bonds, I've got 1, 2, 3, 4, 5, 6, 7, 8 single bonds in this. So there are a total of 2 lone pairs of electrons. Let me just get caught up in the questions here, right? Yeah, Alyssa, you may have to draw a molecule that has, 4 or 5 elements in it. The electron geometry, Blake, is given on the exam. And then how did I know to set this up? Right? Basically, right, we would start with either carbon or oxygen, and it would just be a matter of like checking. I mean, so number one, they gave you in this, they're basically showing you how things are connected, right? Carbon, oxygen, carbon, they're kind of showing you how to link that together. That being said, if we didn't know how to link this together, yeah, we could start with carbon, right? We could start with carbon because carbon forms the most number of bonds. And, right, we could have come up with, the reason why they gave you the structure is we could have come up with something like this instead. That still assigns the same number of hydrogens, carbons, oxygens. The answers all would still be the same in this case, right? So we would know to link it together this way because they gave us in that structure, they gave us, right, carbon, oxygen, carbon. So we knew to kind of link them, to draw them together the same way that they're shown in this structure here. So there might be, 1 or 2 more complicated Lewis structures like this. Question 5, real quick, I guess, came up. Yeah, I mean, we want to draw as shown in that case, right? If we don't have more information to go off of, if we just had the formula, you could come up with the ether here, you could come up with the alcohol here. All these questions would still be the same. All the answers would still be the same because we still have the same number of electrons, the same number of single bonds, right? Oh, okay, the cyanide molecule. All right, so cyanide was on the previous page. Triple bonded to an N. Yeah. Yeah, we might have a question, maybe a question more like question 5 than question 6. Total number of valence electrons in the structure. So I've got 2 electrons here. I've got 6 electrons there. So 6, 7, 8, 9, 10. 10 total valence electrons to assign. Central atom, right, is carbon in this case. Total of lone pairs, right? 0 lone pair electrons on carbon. And then how many single bonds, right? We've got 1 single bond. That's the carbon hydrogen bond right here. We've got 0 double bonds, and then we've got 1 triple bond in that molecule for question 5. Yeah, Grace, that's fine, right? Like I said, I drew this ether because they gave us this structure, right? But I also said if they just said, okay, we've got 2 carbons, 6 hydrogens, and an oxygen, we could come up with other structures. So this alcohol, this is ethanol. This, right, it's got the same number of hydrogens, the same number of carbons and oxygens. And you'll notice it still has the same number of valence electrons. It still has the same number of non-bonding electrons on oxygen, the same number of single bonds. And yeah, in the cyanide, right, a single bond is just one bond. A double bond would be two bonds. A triple bond is three bonds. So they're showing, right, three bonds between carbon and nitrogen. So that's how we know it's a triple bond in question 5. All right, I'll do question 7 and 8, and then that'll be the first video here. Question 7, it looks like they don't give us the structure. All right, question 7, we've got diazine, total number of valence electrons. So for question 7, they don't give us the structure, but we've got 2 nitrogens. Nitrogen has 5 electrons each, so 10 electrons from nitrogen. 2 hydrogens, 1 electron each, so that's 2 electrons, so 12 electrons total. We're going to put nitrogen in the center because hydrogen just has 1 bond, so we don't want to put hydrogen in the center. So nitrogen, I would start with a single bond between those nitrogens, and then I would do 1 hydrogen, 1 hydrogen. So far, we've assigned 6 electrons, right, as bonding electrons. So we've got 6 electrons left to assign. We got to fill the octet of nitrogen. So I'm going to put 1 double bond there. That assigns 2 more electrons. I've got 4 electrons left. So to fill the octet, right, both nitrogens need 2 electrons each. So 4 electrons left. I'm going to put 2 electrons on each of the nitrogens to make sure nitrogen has 8 electrons in this Lewis structure. So total number of valence electrons, right, we came up with 12. The central atom, right, nitrogen. Total number of lone pairs, right? So again, I would say 2 lone pairs, right? 1 and 2. As for single bonds, there's a nitrogen-hydrogen single bond and a nitrogen-hydrogen single bond. There's 1 double bond, right? The nitrogen-nitrogen double bond, and then 0 triple bonds in that molecule. Again, how did I know to draw that Lewis structure? I would just say, right, just some practice, right? I would start with a single bond, like I started with single bonds. There's 6 electrons there. I knew we had 6 electrons left. So we have a few options, right? 6 electrons left. Okay, if I put 2 electrons there and 2 electrons there to fill that octet of the nitrogen on the left, that leaves me with 2 electrons left. If I put 2 electrons here now, I can't fill the octet of that second nitrogen. So that's how we would kind of know, oh, okay, I've assigned all the electrons, but I violated the octet rule for nitrogen. I can't do that. So I want to take these 2 electrons, and instead of them being lone pair electrons, I'm going to share them between both of those nitrogens. And now that'll satisfy the octet of the nitrogen on the right in that Lewis structure. So just a matter of kind of working through the different possibilities, knowing, right, the violations to the octet rule, that we can't do that. So making sure we don't do that as we're assigning those electrons. So making sure we've assigned all the electrons and we haven't broken the octet rule for anything. All right, for question 8, shown in the image is one possible structure, fulminate. What are the formal charges on each of the elements in the structure? All right, so formal charge is group number minus assigned electrons. So carbon is group 6, nitrogen's group 5. Sorry, carbon's not group 6. Carbon is group 4, nitrogen's group 5, oxygen is group 6. For our assigned electrons, we count all non-bonding electrons, and then we're going to count, right, there's 2 electrons here. We're going to count 1 electron for each bond. So right now in this Lewis structure that's drawn, even though carbon is group 4, carbon has 1, 2, 3, 4, 5, 6, 7 electrons assigned to it. So that would put a -3 charge there. Nitrogen is group 5, and it's got 1, 2, 3, 4 electrons assigned to it because we're going to count 1 electron for each bond. So 5 - 4 + 1. Oxygen is group 6, and this oxygen has 1, 2, 3, 4, 5 electrons assigned to it. So 6 - 5, a +1 on that oxygen. So our total charge ends up being -1, right? Because this cancels out one of the -3, and that cancels out one more of the minus charges, leaving us with an overall charge of -1. This is not a great Lewis structure, though, because we want to, number one, minimize the number of atoms that are carrying charge. And if we're carrying a negative charge, we'd rather it be on the most electronegative atom, right? So we don't want the negative charge on carbon. We'd rather have it be on oxygen in this case. So we want to dump in some of those electrons from carbon. All right, that wraps up question 8. I'll pause the video here.